This tutorial will give you an introduction to the AP workbench. It's used to create, simulate, and compile designs for the automata processor. The example I'll be using is a simple regular expression that matches on all spellings of the word donut. Before I show you how to build it, I'll show you how it works. I go to the simulator using this button. This is the simulator view. Across the top are the symbols that will be sent to the machine. We call this the symbol tape. Our regular expression automata will process this sequence and report when it finds a match. This example has a D, O, N, U, T, followed by some junk characters and then a different spelling of donut and so on. Over here are the simulator controls. I'll get back to these in a moment. Each of these nodes is a matching element. This element matches on the letter D. This one matches on the letter O, and so on. Brackets are optional, but I put them here to remind me that this node matches on a space character. Starting out, we're at time 0 before the first symbol has arrived. This node is the start state of our machine. It's configured to compare against every symbol in the tape. Right now it's orange to show that it's an activated node. I press the forward step button. The symbol tape advances to the letter D, and our start node lights up green with a match. When a node matches, it activates any nodes it's connected to. So now the O node is orange. It will be looking for a match on the next symbol. I step again. The O node finds a match. It's green, and activating the nodes it's connected to. Remember, our start node looks at every symbol, so it's also comparing against the O. It's red, showing that it does not match. Now there are two symbols that can advance the machine, either an N or a U. When I step forward, the N has a match and the U does not. As I continue to step forward, you see the machine advance until it finally reaches the end state. The end state is special. When it matches, the automata processor will report the ID of this node and the current symbol count. I've given this node a special ID, so in this case, the processor will report found a donut, matching on the symbol number 4. The processor can be packed with thousands of these machines running in parallel. These IDs tell you which ones are finding a match and when. Up in the symbol tape, this number 1 indicates one reporting node is matching at this time. I can hover or right-click to get a list of the reports. As I step ahead, the machine ignores the junk symbols. Then it follows a different set of matching nodes before we reach the end state again. For this example, all spellings are equivalent. But I could just as easily create a machine with one reporting state for each possible spelling, if that is what is needed. Before I leave the simulation view, let me show some of the other controls. I can hit play, of course, and control the speed of symbol arrival with the slider. I can jump to the end or back to the beginning. Suppose I'm interested in what the automata is doing when this white space symbol is active. I can double-click on the number of the symbol to jump to it. Using step forward and step back, I can see the events before and after any behavior I'm interested in. Now, I'll build the donut machine from scratch. Create New Project is an option at launch, or you can call it from the File menu. Set the project name in the dialog box and click OK. Drag in the element type you need from the palette. This design only uses matching elements, but the palette offers counters and booleans as well. Matching elements are the most common resource in the automata processor. Double-click on the node to enter the symbols that you want it to match on. We've been looking at single characters, but you can enter multiple. This will match on either an uppercase D or a lowercase d. You can enter a range, so now this will match on all capital letters. You can add a caret to negate the expression. This will now match on all symbols except capital letters. You can also use hex characters. The online documentation explains all the options. The node's properties are here in the lower right. I can edit the properties on the current node, or I can set using the Edit button. I've selected all symbols. Now you see the wing on the upper left with the infinity sign. I'll add my second node, set it to O, and my third node for N. I have a couple of options for making connections. I can drag forward out of a node, or I can drag backwards out of a node. Now I'll just repeat this process for the rest of the design. On the last node, I'll use the Edit button again and set it to Reporting, and to set the ID string. The tool will automatically generate unique IDs for the rest. I made a mistake in this design. The connection is in the wrong direction, leaving a node as a dead end with no path to a reporting node. You can validate the design at any time by clicking this button. I get a warning, and a double click on the warning highlights the problem so I can make the fix. Validate again, and we're in the green. Now I'm ready to simulate the design. I can also export it or compile it. Note that the APSDK must be installed separately from the AP workbench. Thank you for watching this tutorial on how to create and simulate simple automata. Please watch the other videos to see different automata in action, and sign up to get early access to the SDK to create your own.